Thank you. Okay, so we are going to be building fluency today with all the count bys we have discussed. Can anyone remember the count bys we've discussed so far? What's one of them, Serne? We have talked about tens. What else? Yes. Nines. There we go.
Five.
Tens, nines. What else?
Fives.
Fives. Thank you at home. Sunny? And twos. So fluency is just like reading fluency. It is when you can do it smoothly. You don't have to think so much. So that's why we're going to work on that. We want to be able to be quick and efficient as mathematicians as we solve real world math problems that involve these count bys. We're focusing on multiplication and what else? Division. Max, I need whole body. So we're going to practice our count bys. We're going to review some things from Friday and do some problem solving. So I'm going to start with our multiplication chart, and let's look at the 5 since we started with that. I am just going to give you an equation and I want you to solve it, and then when you know the answer, raise your hand. The question is, what is 7 times 5? 7 times 5. You can put it in the chat if you're at home, or you can raise your hand. 7 times 5. You can put 7 fingers up and count by fives. I see 1, 2, 3, 4, 5, 6 hands, 7 hands up here. If your hand is not up, you are counting by 5 7 times. All right, and I'm going to pull out of the can, so make sure you have the answer in your head. Hands and feet are down and still unless you're using them to count. Ryder is in 4th grade. Meh. Charlie V, 7 times 5. What does it equal?
57.
Let's try it. 5, 10, 15, 20, 25, 30, 35. 35. Now I'm going to give you another one. What is 45 divided by 5? 45 divided by 5. Write it in the chat or raise your hand when you know. 45 divided by 5. Count by 5s till you get to 45. I'm looking in the chat.
Robert's got the answer.
Oh, I see.
We don't have the same ones.
I see Leo figured it out. Leo, can you unmute and share?
9.
9. Let's see if he's right. 45 divided by 5 just means how many 5s are in 45? Let's count. 5, 10, 15, 20, 25, 30, 35, 40, 45. Or you could have looked at our board, right? And you could have said, here's 45. Divided by 5 is 9. So you could have looked at our multiplication chart and done the inverse or the backwards. All right, so then after 5s, we went to 2s. So I'm going to give you 2 times 9. 2 times 9. When you know the answer, raise your hand. And I'm going to pull out of the can. Elena, what you got going on there? Okay. 2 times 9. Max. He said 18. If you agree, give him a thumbs up. How do you know, Max? 9, 2s, and 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. So,
Robert's rocking it today.
Robert, good job. I hear you're rocking it. So then what is 18 divided by 2? 18 divided by 2. This one should be very simple. How many 2s are in 18? Let's pull out of the can. Marin's not here. How about Ethan's not here? Evie. How many 2s are in 18 then? 18 divided by 2. 9. Give her sparkles if you agree. I see my chat is exploding. Yay, Gavin got it. 18 divided by 2 equals 9. Gavin, I like that symbol you used. Nicely done. All right, next one. We then learned our tens. 6 times 10. Raise your hand when you know it. 6 times 10. You can use the chart to help you. Henry, what is it?
60.
60. Give a double thumbs up if you agree with Henry. All right, a lot of people got thumbs up for you, Henry. 80 divided by 10. 80 divided by 10. Sawyer. 80 divided by 10. How many tens are in 80? I hear microphone answer. 8. All right, then we're going to do the nines was our next one. 3 times 9. Okay, can you tell Mrs. Harrison? 3 times 9. Leo's got it. All right, I see 1, 2, 3, 4 people have figured out 3 times 9. Noah. 4th grade, another 4th grade. Josh Carter. 3 times 9. Is anyone doing this? Did anyone put their third finger down and count the fingers to the left and the fingers to the right? If you didn't, try it out. 20. 1, 2, 3, 4, 5, 6, 7. 27.
All right, I gotta say, Jensen.
27.
Benson and Robert, you are my rock stars today. Keep it up. Gavin, too. He's
Hey.
really on it. All right, we've got one more. Division. Let's try this one. 27 divided by 9. 27 divided by 9. Gabe, how many 9s are in 27? Looking here. 9, one more 9. Well, or what did we just do? We put our third finger down, right? So how many 9s are in 27? Look up here. 3 times 9 equals what? 27. So 27 divided by 9 must equal 3. All right, good job, you guys. So we are going to watch this one more time because I still don't think we have been using our 9s trick. It is. And Henrik was gone, so you need to listen. I want you to try it again. This is our 9s trick.
And we can show it if we fold down one finger or thumb at a time. Starting with your left thumb, you can now number all your fingers up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Are you guys doing it?
Now, if we want to know what 1 times 9 is,
Let's do 1 times 9. Henrik, you ready?
hold it down close into your hand.
Hold on your first finger for 1 times 9.
9 fingers still standing. So 1 times 9 is 9. Okay, put your thumb back up. Now we can do 2 times 9.
But this time you put your second finger down.
Fold down your first finger, the one we called 2. On the left, that finger is 1 thumb, and on the right are 8 other fingers. 1 and 8, that's 18. So 2 times 9 is 18. In maths, we often talk about numbers being in the units column or the tens column.
We call it ones instead of units.
Tens on the left of your folded finger, units on the right.
Or ones on the right.
Try the same again as 3 times 9. Fold down the middle finger, number 3.
Put your third finger down. This is the one we did, right?
Right a bit. Our second fingers,
So 3 times 9 is
tens,
27. Pretty cool.
20, and 7. 27. 3, 9 is 27. This works all the way up to 10 times 9. By the time you get to the thumb on your right, you will have reached 10 times 9. So, fold that down, and you've got 9 fingers standing on the left of the thumb, and nothing.
That's if you're doing 9 or 10 times 9.
0 is 90.
It works for all of them, you guys. The fingers to the left are your 10s. The fingers to the right are your 1s. Well, you'd have to use your toes, right? That could be a little tricky. All right, let me get out of that. I can't get this to move. There we go. All right, so that is a little bit of a review. And here it is again. I just want to remind you, and as we did our 9s, I noticed we weren't doing it, and that's probably because it's been the weekend time and we probably have forgotten. So use that quick 9s method to help you multiply by 9. You can do it this way or this way, Ryder. Do you guys need help?
No, I'm just asking.
Okay. You can use your hands this way or this way, but make sure you're thinking of them as numbered from left to right, just like we read, right? We read from left to right. You're going to number them from left to right, just like in the picture here. Any number that you want to multiply by 9, bend down that finger for that number. For example, to find 4 times 9, everyone do it. Ready? Put down your 4th finger. 1, 2, 3, 4. And now we have what, Henrik? How many fingers to the left? Henrik, I need you to do this. This is pretty much for you because you left, right? Show me. How many fingers are to the left of that 4th finger down? How many are to the right, Henrik? But you got this one too. 6. So see, 36. What's 4 times 9 equal? 36. I want to review this because some of you at home did your exit tickets. Not everybody did, but boy, the ones who did, amazing job. And I believe it was Robert who explained how to figure out 4 times 9 using the tens trick, which is what Paxton was telling us about. If you know what 1 times 10 is, you can use that because think 9 is 1 less than 10. So if you take 1 away from that, you can find out 10 minus 1 is 9. So 1 times 9 is 9. When you know 2 times 10 is 20, 2 tens is 2 less than that. So 20 minus 2 is 18. So 2 times 9 is 18. 3 times 10 is 30. So if I want to know what 3 times 9 is, I just have to take 3 ones away because of each 9 is 1 less than 10. So then I would get 27. 4 times 10 is 40, so take 4 away and I get 36 if I want to find out what 4 times 9 is. 5 times 10 is 50. If I want to know what 5 times 9 is, I just take 5 away from that 50 and I'll get my answer, 45. 6 times 10 is 60. If I want to know what 6 times 9 is, I just take 6 away and I'll get 54. 7 times 10 is 70. So if I want to know what 7 times 9 is, I take 7 away from 70, I get 63, and 7 times 9 is 63. And I'm going to call this Paxton's trick, right? The tens trick. If I want to know what 8 times 9 is, I can think about, oopsie, 8 times 10 is 80. Minus 8 is 72, so 8 times 9 is 72, and so on. All right. So I can do the same thing with 9 times 10 is 90. Take 9 away, I get 81, so 9 times 9 is 81. All right, that is the tens trick that we talked about on Friday. Now today, we're gonna build our fluency with 2s, 5s, 10s, and 9s. We've learned a lot of count bys, but we're gonna be solving word problems. So I want you to read the problem. I want you to visualize. I want you to retell it. I want you to interpret it, use clues to find relationships. We're focusing on 2 operations. Who can unmute at home and tell me what 2 operations that we've been focusing on? Blank and blank. Blank and blank. What are they? I'm looking for someone who can unmute and tell me. It's not addition and subtraction. Jensen, will you unmute and tell us? No. Astria, can you tell me these 2 operations? Which 2 have we been focusing on from the beginning of the year?
Division and multiplication.
Thank you so much. Yes, so we're going to look for clues. How do we know? Then we're going to model the relationship by drawing a picture, and we're going to reflect, put that answer back in. Okay, so when we do this, before we do this, I want to show you something, and Haley keeps getting kicked out, it looks like. What were the clues we came up with that tell us whether to multiply or divide? Who can tell me? And I wrote them down, so I'm going to try to find them here. We can talk about them again. Here they are. Anybody remember? How do we know when to multiply? How do we know when it's a division problem? Yeah, go ahead, Evie. Well, that's how we know what, yeah, we use a symbol to show the equation, but if it doesn't have that in the problem, what do we do? What clues? When it said in there, look for clues, like you're a detective when you're solving word problems. Do you guys remember? Paxton.
You look for the total.
Yay! So if I am looking for the total, am I multiplying or dividing? Paxton? No, actually, when you're looking for a total, you're multiplying. So let's go back. Multiplication is the inverse of division. It's repeated addition. You are looking for a total number. So if it's asking you to find out, I have 4 sheets of stickers. There's 5 stickers on each sheet. How many stickers do I have? That's multiplication. I'm trying to find how many are there all together? But if it's division, it might say something like, I have 20 stickers. I want to divide them equally amongst my 4 friends. How many would each friend get? You got to visualize that. I'm passing them out in equal groups. We're dividing it up. If you have this number, you are looking for the number of group or group size. That's divided. Just like the book we read, When the Doorbell Rang. Do you guys remember reading that? I'm going to grab it because I feel like it might help you. Not going to read it again, but when we read The Doorbell Rang and you guys had those manipulatives and we knew we had 12 cookies and then people kept coming over and we had to give those cookies out equally. We had to share them, fair shares. Then the doorbell kept ringing. We wrote, that was the first day we did division. We wrote division problems because we had the total. We didn't need to know how many cookies we had. We knew there were a dozen. There were 12 cookies. We needed to know how many cookies each person was going to get. That is division. You take your total, you break it into equal groups. You do. This is multiplication. The best thing I can tell you is to think, am I finding a total or am I breaking into groups and I already know my total? So let's see that as we saw today. I'm going to have you go a little backwards and turn to page 44. And the reason I'm doing this is because I thought if I teach you this little strategy, it's another drawing, which problem solvers do. You can use it to help you with some of the other problems. Okay, so this is called a fast array. We talked about arrays the other day. I brought in the muffin tin. I brought another array in, actually, because I thought to be recycled, and I thought, I'll grab that from Matt. I've been holding on to it. It's this egg carton. Why would I say this is an array? Why is this an array? And I'm going to show my friends at home. I brought in this egg carton as an example of an array. Sunny, why is this an array? Two rows of what? No, it's a dozen eggs, right? So it has to be 2 rows of what? 2 rows of 6, or 6 rows of 2. An array is just a picture, usually of dots, right, that has equal rows and columns. It has rows and columns. Yes, did you want to add on, Ellie? Yeah, we have bins in the classroom with holes that show arrays. We talked about muffin tins being arrays, the twister board being an array. So what we're going to do is we're going to come up with another strategy, another tool for your toolkit on how we can solve some of these problems. So this is called a fast array. Everybody say that with me. Fast array. Serene, did you have a question? Okay, so fast arrays are very similar to a regular array that we've been talking about. They show the number of rows and the number of columns. So when you make a fast array, you're just not filling in all of the dots, because when you want to do something like 9 times 6, if you were to draw that, it would take a long time to make 9 rows of 6. So instead, you can do it a different way. You can draw the dots going across for the number in each row and the dots going down for the number of columns, or rows and columns going across. So here are the ways to find 5 times 10. They went ahead, and if you can see this little pencil here, and you can look in your book on page 44, you have 1, 2, 3, 4, 5 dots going down. How many do you think are going to be across? 10. Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a visual representation that tells me I need to multiply 5 groups of 10. But I'm not going to draw all of those in. I know from this picture I can just count by what? 5s or 10s. So you could use 10s. Let's count by 10s 5 times with me. 10, 20, 30, 40, 50. So I know that 50 is the answer. Or I could have counted by 5s 10 times. It would probably go the other direction. You could also use a fast array to help you divide. So if you know the total, you would put the total down here and your divisor across the top. And then you'd be able to find the, so you have your dividend, you have your divisor, you'd find your quotient here. All right, or if it's not division and you want to do it as a factor, you could think of it as a factor because they're related, they're the inverse. So let's look at these 2 problems and show how that fast array works. So I am going to, hold on, let me escape for a minute. Let me get out of this. I'm going to read this to you. Somehow I ended up on a pen. I've never seen this pen in my life. let's go back to mouse. There we go. Beth planted tulip bulbs in an array with 9 rows and 6 columns. How many bulbs, oopsie, let's go back. And I want to go here. How many bulbs did, these bars get in my way. All right, well, because I can't finish reading it. Can anyone help me finish reading that? How many bulbs, there it is, did she plant? So 9 rows and 6 columns. How many bulbs did she plant? We are gonna quickly try to draw that array. It's the same one we just did because we wanna know if we have 9 rows and 6 columns, that's a lot. Remember how they showed you at the top? Look at the top. We are going to draw 9 across. Oh no, this is different. So if we have 9 rows, here I go, and 6 columns, I'm going to draw 1, 2, 3, and this is not aligned, so let me align it. 1, 3, 4, 5. Let's see if I can do. So draw this with me. And you guys should have more room than I do. You want to go 9 rows, which means it's going to go across. So I want to do 9. 1, 2, 3, 4. Oh, it's not aligned still. 1, 2, 3, 4, 5, 6, 7. 7, 8, 9. I'm going to just do it like that. Yours will be straighter. So those are my 9 rows. If I have 6 columns, that means I need 6 going across. I have 1 here, 2, 3, 4, 5, 6. So I've got 6 and then I've got 9. What I don't want to do is have to fill in all of these. But it tells me a little bit about the problem. If I know I have 9 of these rows, right? They're all going across. And there's 6 in each. This picture, this fast array, helps me realize what operation I have to use. If I want to know how many bulbs she planted, and she has 9 rows with 6 in each, am I going to multiply or divide? Looking at this fast array, what do you think? I see one hand up. I see fingers. I see multiplication signs. Let's go back here. What did we say about multiplication? What did we say about division? Multiplication is repeated addition. You are looking for a total. Division, you have the total. You're breaking it up. Serene, I see your hand. What do you think? I don't know the total, so it can't be division. It is multiplication if you agreed. If you said multiplication, give yourself a pat on the back. You were listening. Repeated addition. I have 9 rows of 6. I could add 6 9 times, or I could add 9 6 times. I would suggest, because this is a tough one, I would use the 9s trick. Oh, a big shout out to Astria. Immediately, she's like, I'm not going to count 9 6s. I don't want to count 6 groups of 9. She got her fingers out. She's putting her 6th finger down, and she is figuring out the answer. I want you all to do the same thing. Go ahead and write the equation. 6 times 9, or you can write 9 times 6 because of commutative property, and see if you can do the fingers, the 9s trick. What is 6 times 9? Write your answer. I see fingers moving. Oh, Gabe, I'm so proud of you. Good job. I love Charlie's doing it. I see Reese is working hard. Good job, Reese.
So it's Ben and Pat and Katie.
Thank you, Ben and Katie. Awesome.
Haley is in a car showing me her finger, but I can't quite see it.
Okay, thank you, Haley, for trying. So we're going to put our 6th finger down. How many fingers are to the left of that finger for our tens place, our tens digit? Microphone answer. 5. How many fingers are to the right of that 6th finger? Henrik.
4.
Right for our tens. Henrik, what about our ones? How many fingers are to the left? Count them. Put your 6th finger down, honey. Can I see your fingers? Sit up, sit up. Put your 6th finger down. So 1, 2, 3, 4, 5, the 6th one. Yeah, it's tricky. How many are on the right? Say it loud. He said 4, so the answer is 54. Good job, Ben and Haley. And our unit is bulbs. Let's reflect and make sure this makes sense. Beth planted tulip bulbs in an array with 9 rows and 6 columns. She planted 54 bulbs. Is that reasonable? 6 groups of 9? Yeah, that's a big number. If I think 6 times 10 is 60, oh, I could use that 10 strip. I'm thinking if that's reasonable, and I know 6 times 10 is 60, and if I subtracted 6, I'd get 54 like Paxton taught us on Friday. So I think that's reasonable. All right, so let's try the fast array for division. And I know this is a little tricky, but we'll keep working on it. The 36 students in the chorus stood in 4 rows for their school picture. We should all be able to visualize school pictures. We've done them. 3rd grade, we've had them since kindergarten, right? Where we get on the bleachers. So picture that. We have 36 students in the chorus. They're in 4 rows for their picture. How many students were in each row? Show me if you think we're going to multiply or divide. And before you do, be able to defend it. Let me put this back up. When we are multiplying, we're looking for a total. We see repeated addition. When we are dividing, you have the total. You are looking for the number of groups, like in each row, or the group size. So now maybe tell me what you think. I see different symbols. Show me this if you think it's multiplication. Show me this if you think we're going to divide. I see, we're getting there. We're getting there. This is exciting. Reese, can you unmute and tell us?
I think we're gonna divide because we already have the total. We don't need to find it.
Hallelujah. You're right. That makes me so happy that you said we know the total, right? If we multiplied 4 times 36, we'd be in like 130 something students in each row, and that doesn't make sense. There's no way. We only have 36 students. So yay, good thinking. So let me do a fast array. Try it with me. And this, you don't have to use fast arrays. It's just another tool for your tool box. So 4 rows. That means I'm going to draw 1, 2, 3. Because I've already aligned this, it doesn't like me. I'm going to draw over this. 1, 2, 3. Here's my 4 rows. I don't know what this is because I already know that I have 36 here. Here's my 4. 4 times what is 36? Or 36 divided by 4 is what? What I don't like about this problem is we haven't done 4s, so it's tricky. So I'm going to give you guys a hint. I want you to show me 36 on your fingers. If you put a 4 down, your fourth finger down, you should get 36, right? So we should know what that missing factor is. Yes, it is 9. But that one was really, that was tough, right? Because we haven't learned our backup here. We can always look there at 36, yeah. So if you did not hear us, we said the missing factor is 9 because we've been practicing putting our fourth finger down. We got 36. We haven't learned our 4s yet, so I know that was tricky. So go ahead and write that equation. 36 divided by 4 equals 9. Or you could write it as a missing factor problem. You could use a variable. Did anyone want to try that? 36, here's my 36, divided by 4 equals S. And then S equals 9. You guys remember our variables? Or you could have even said 4 times S equals 36. Because they're inverse. It doesn't matter. You can figure it out how you like. For that, we haven't done our 4s yet. Show me thumbs up when you have the. So if you might like using a faster page, you can draw all of those dots in. Raise your hand if you like the faster page. I might try them. Raise your hand if you're like, try like that. I hear you. Another tool on this box. Yep, another tool, and everybody finds their niche. My son learned how to multiply with what were those Pearson? Oh, the box that you would draw the lattice, and it drove his teachers crazy when he came to English. But he still uses it as I'm here and try again. But I could never do it. I love it. We all find our niche and what we like and what works, and that's good. All right, so looking at page 43, we're not going to spend a ton of time, but yeah, I did it backwards because I thought it was silly that I would show you a strategy after, so I decided to do it the other way. Back in time. Yep, so you're going to have to go backwards to page 43. We are going to try to do the first 2 problems on our own. Actually, if you're okay doing a breakout box, I'd like for them to work. And we could do groups of, how many kids do we have today?
11. Or no, 10, because you and I.
So maybe we do pairs, it'd be easier then.
Okay.
You guys are gonna get into a breakout group. I want you to do numbers 1 and 2. If you're struggling with the reading, can I borrow this? I'm gonna read them for you real quick. You can underline your important information. The first one says, Ian planted tulip bulbs in an array with 5 rows and 10 columns. How many bulbs did he plant? You have to figure out if it's multiplication or division. Draw a picture, do what you need to do, share with your partner what you think it is and what answer you got and the equation you're gonna write. Then number 2, Erin gave 30 basketball cards to her 5 cousins. Each cousin got the same number of cards. How many cards did each cousin get? Okay, so you are gonna do those 2 problems in your breakout room. You guys are gonna do it with the person next door to you. All right, I'm gonna give you as much time as needed. We'll check in with you in about 6-7 minutes. We'll see how we do. Good luck. Okay, do you guys have a partner? You guys talk it out. Talk it out, write your answers, see if you can figure out if it's multiplication or division, and how do you know? Who's your partner? Sawyer, so you guys get started. So talk it out. So the first thing, the first problem solving is the problem here. Okay, you got
Hey, Henrik, if you're gonna work with her, can you turn around? It's hard enough to hear when she's on the phone. She made it. Quick question, did you label your answer? Uh-oh, spaghettios. You should be labeling your answers. If you finish, you can try number 3. If you finish, try number 3. Some of us need another minute. If you're finished, try number 3. Lucas and Cooper, go for it. Lyra, go for it. Show me on your fingers if you need 0 minutes or 1 minute. 1 minute, okay. Okay.
Are you ready for me to unmute?
I am. Welcome back. All right, let's see how we did. I'd love to hear from somebody at home or remote. Jensen, do you want to unmute and share what you and your partner came up with for number 1?
We came up with 5 times 10.
Can you tell us why you thought it was multiplication and not division?
Because you can't do 5 divided by 10, but you can do 5 times 10.
Okay, what were we looking for? We were looking for the what?
The answer?
The total of bulbs, right? So when we're looking for the total, what are we doing? Multiplying. We didn't know the total, right? So we had to find it, and that's repeated addition. 5 groups of 10 or 10 groups of 5, however you want to think about it. What was your answer, your product?
It was 50.
50. If you agree with him, give him a thumbs up. I hope every thumb is up. Good job, Gavin. Good job, class. Everybody's got it. And did you label your unit? 50 what? We should have said bulbs, right? They look like big seeds. Good job, Max. All right, I'm going to pull out of the can. Next, I always pull someone that's not here. Haley Booker. Haley, what did you get for number 2? Okay, who can help her out? Lucas, what did you get? 30 divided by 5 is 6. 6 what? What is your unit? Cards, very good. 30 divided by 5 equals 6. And how did you know it was division and not multiplication? Can anyone help with that? Why did we divide and not multiply? Cooper, you were his partner, right? Yeah. And what are you doing? You're dividing them up. And I'm going to go back again to our book we read about division. We knew we had 12 cookies. We had to share them. It's the same here. Erin had 30 basketball cards. She was giving them to her 5 cousins. How funny. That's who kept coming over here, right? The 4 cousins. When we hear cousins, we know we're dividing. No, I don't know that. Just kidding. So good job, you guys, deciphering between the two. That's what problem solvers do. They look for clues. You're detectives. How do I know what I'm doing? You're visualizing. Let's go back and reflect and make sure these both make sense. If Ian, and I'm going to borrow August's book again. If Ian planted, where was it? Page 43. Ian planted tulip bulbs in an array with 5 rows and 10 columns. He planted 50 bulbs. Does it make sense? Is that reasonable? Yeah, if he has 5 rows with 10, sure. If I would have divided and got 2 as my answer, it wouldn't have made sense. Oh, we only planted 2 bulbs. Well, how could he have done that? If each row we had 5 rows and 10 columns, it wouldn't have made sense. All right, number 2, Erin gave 30 basketball cards to her 5 cousins. Each cousin got 6 cards. Does that make sense? She had 30, there's 5 cousins, they each get 6. I can see that. That makes sense. If I would have multiplied and got 150, I would have said, whoa, how could each cousin get 150 cards when we only started with 30? That would not be reasonable. So good problem solvers are always reflecting. Make sure you're doing that. I am really proud of you guys. So let me erase that. Show me on your thumb how you're feeling about your 2s, 5s, 10s, 9s, solving these problems today.
Everyone at home, show me your
Do we have
thumbs.
a song? Not today. I didn't do a song.
Can you remind my
I know.
friend?
How are you feeling?
Just go to a random, go to one of those
Okay, so I had a few of you already do this at home, but most of you did not. So I attached this exit ticket again. So in person, listen, you guys are going to get your exit tickets for number 3. Here's what I want you to do. You're going to explain in words how you would find, thank you, the answer to 4 times 9 using a tens multiplication or the quick nines method. And I can tell you who already did that for me, my remote kiddos. I know I was so impressed. Ben, you got a 4. Good job, Ben. Jensen, I gave you some feedback on yours, so I want you to read that. Haley, you got it. Robert, you got it. Henry, you already did it. But I still need to hear from Clara, Astria, Gavin, Katie, and Reese. So if you're not sure what I'm talking about at home, when you go here, you click on this and you type in your answer, and when you turn it in, I get to see your work. It just says explain in words how you would find the answer to 4 times 9 using a tens multiplication or the quick nines method. Okay, so then you guys, I see questions. Gavin, did you have a question?
Well, it's not a question. It's
Okay.
it's something that so it would be cool if you tested me for my good 13's timetables.
So when we are doing our math mad minute we do, or whatever we call that, I forget. We do it twice a week. You just have to prove to us that you have the others memorized, and then we could do it. Okay, so as long as you pass all the others, is that okay, Mrs. Harrison? We'll let you. Yep, we're gonna do the ones first, and we gotta make sure you master those, okay? And then we'll see how you do. All right, any questions from my remote learners? Okay, guys, make sure you turn in that exit ticket, and you can work on Think Central assignments if you have time, extra time. Whatever is not finished, I would go with your lower number, like lesson 1.6 or 1.7, because most people haven't had time to do those. All right, then I will see you guys tomorrow. Great job today. And then I'm gonna just quickly try to, oops, sorry guys, stop sharing.